have, if you have 3-degree alcohol, in that case reaction does not stop at the esterification step. It undergoes further reaction and undergoes a further cleavage therefore to form a carboxylic acid and an alkyl halide. So this is again the drawback in this reaction. So now again what we want is that we want this reaction to stop at the esterification step. So for that matter what you need to do is you remove HCl as soon as it is formed. What you do is you remove HCl as soon as it is formed. Now when you remove HCl, then what will happen is that the reaction will stop at the ester formation step only. So now the question is that how to remove HCl. Now because HCl is a acid, so if you add some base into it, what will gonna happen is that acid base neutralization reaction will take place, and hence the reaction will stop at the esterification step only. So therefore, to remove the HCl over here formed in the reaction, what you need to do is you add some base into it, and the base which we add generally is the N-dimethyl aniline. So in that case what happens is that this is electron rich, very electron rich compound, N-dimethyl aniline, and a strong base. So what happens is undergoes a reaction with the HCl, and hence it removes HCl from the reaction. So therefore the reaction stops at the esterification step itself. But the next thing is that again the question, the first question I asked about was that it is the H of the acid and the OH of the alcohol, or the OH of the acid and H of the alcohol. What combination of these two takes place in the esterification reaction? This is the first thing. And the second thing is that the reaction is reversible in nature. How can we convert the reaction into the forward direction? For that I have already discussed two methods. One method is the add benzene as a co-solvent, and that will act as a then benzene water azeotrope formation will take place. Once the azeotrope is being formed, then you will say that it will evaporate or boil at 69 degrees Celsius, which is highly achievable in any of the laboratory. Now after this we also discussed about one point, that how can we convert the direct reaction into the forward direction. Now after this the last question regarding the esterification concept is like we are given 3-4 types of alcohols, we are given 3-4 types of acids. We got to arrange them in the increasing or decreasing order of the rate of the esterification reaction. Now suppose let me take an example for the carboxylic acid first of all. Now what we have is this, that suppose we have a carboxylic acid HCOOH and we have CH3COOH, then we have CH3CH2COOH. So basically if you see the mechanism very carefully, after the second step of the mechanism, what you can observe is that there is a positive charge on the carbon, that is a carbonyl carbon only. So in case of HCOOH, CH3COOH and CH3CH2COOH, in all these cases again there will be a positive charge on the carbonyl carbon. Now once it has a positive charge, the next question is about the stability of this C positive charge. Now after this step actually what happens is that the nucleophile, which is the lone pair of the oxygen atom in the alcohols, they basically act as a nucleophile and attack on the C positive carbon. But actually in this case what will happen is that now you can observe that if the C positive carbon has a higher magnitude of, or you can say the more deficiency, then nucleophile will attack very easily and hence the reaction will be very fast. But if suppose the C positive carbon has already got electrons from its surrounding groups, then what is the use of taking the electrons then from the nucleophile? So therefore the moment you increase the R chain, that is a chain of the alkyl groups, what it will gonna happen, they will slow down the rate of esterification. So this is the way to identify that which particular assay will undergo esterification reaction faster or slower. So basically now in this case, what you can say is that the larger the R group in the carboxylic acids, slower is the rate of esterification. The reason is that if the larger is the R group, that will gonna decrease the positive charge on the carbonyl compound, and hence the attack of the nucleophile becomes slower. So this is the rate of esterification concept with respect to the different kinds of carboxylic acid.